And we will start with the first approach, that is looking at AI as acting humanly. This approach is also known as the Turing Test approach from the computer scientist Alan Turing. So let's look into what the Turing test is. The Turing test was designed by Alan Turing in 1950, about 70 years before this time, to provide an satisfactory operational definition of intelligence. So he set out to define intelligence, an operational definition of intelligence, so that we could design intelligent agents. So the definition of intelligence was needed for AI because the goal of AI was to build artificial intelligent agents. So unless we had a definition of intelligence, a working definition of intelligence, how can you design artificial intelligent agents? So Alan Turing proposed that instead of asking whether machines can think or not, we should ask whether machines can pass a behavioral intelligence test. So instead of arguing whether machines can think or they are actually doing what humans are doing, he said we should design a test such that we put the machine through the test, and if the machine passes this intelligent test, then we say that the machine is also acting humanly or intelligent. Specifically, here's the Turing test. So according to Turing test, a program is supposed to have a conversation with an interrogator for 5 minutes. So say here's a human, a dummy, an actual human, sitting in a computer screen, and let's say our agent is somewhere else, wired to this screen. So this program, your artificial intelligence program, is to have a conversation with the interrogator. So here's your interrogator, actual human, right? And here's your computer screen. They're supposed to have a conversation for 5 minutes. And the interrogator has to guess if the conversation is with a program or a person. So this person will continuously type and chat with the AI agent, and he has to guess whether this AI agent is actually a computer or a real person having a conversation. And the program passes the test if it fools the interrogator 30% of the time. So out of overall in 5 minutes, if the AI person fools this individual or interrogator into thinking that this AI is an actual program, and if we repeat this, and if the program is able to do it 30% of the time, then we say that this AI program has passed the Turing test. Now you may think that since we are very frequently these days fooled with computer algorithms like telephone calls, recorded telephone calls, and so on, you may think that this may be very easy. However, for the Turing test, the interrogator already knows that this thing could be AI or a person. So the interrogator has now extra eyes and ears to carefully examine, check, and come up with a decision about whether this this agent is actually human or an AI. And Turing conjured that by 2000, by the year 2000, a computer with a storage of 10 to the power 9 units could be programmed well enough to pass the test. So that's what he had imagined. Unfortunately, even 20 years after 2000, we still do not have programs that can convincingly pass the Turing test. So many people have been fooled when they didn't know that they might be chatting with a computer, and that's what happens. We have chatbots that act like humans. However, when you know that you could be chatting with an AI agent, you have extra eyes and ears to become careful and to be less fooled. And to keep track of how well AI is doing to pass the Turing test, the Loebner Prize competition is held annually, where the competition basically organizers organize Turing-like contests for participants to compete with each other. Now, even though so far, since the competition was started, we haven't been able to convincingly pass the Turing test. Um, because of those competitions, people have built methods that are very good at checking and finding out human typing errors and auto correcting them and so on. So in general, Turing was wrong. Computer programs have yet to full sophisticated JAWS, and um, programming a computer to pass a rigorously applied test provides a plenty to work on. There's a lot of things we have to do to pass Turing test. Now, Turing deliberately avoids the direct physical interaction between the interrogator and the computer. That is, he intentionally designed the test such that your agent could be somewhere else and your interrogator could be somewhere else. That's because, by the definition of intelligence, he defined intelligence in such a way, or he believed that for checking intelligence, physical simulation of a person is unnecessary, because we can be intelligent even over the telephone or through chatting and so on. Now, people have extended the Turing test to make it more challenging and more comprehensive. One example is the total Turing test. The total Turing test is an extension of the Turing test, where this test includes a video signal as well, so that the interrogator can test the subject's perceptual abilities as well, and the opportunity also providing the opportunity for the interrogator to pass physical objects through the hatch. So in the total Turing test, we are not just testing the intelligence of the agent, but we're also testing perceptual abilities and its ability to manipulate objects and so on. Now, for passing Turing test, we don't need all kinds of AI skills. For example, if we look at natural language processing, we naturally need this to pass the Turing test. Computer vision, however, is not needed to pass Turing test. Knowledge representation is definitely needed, because somewhere the agent needs to store the knowledge that it has learned previously and by interacting with the interrogator. Automated reasoning is also needed. Robotics is not needed, because in Turing test, the agent is not expected to handle or manipulate objects. Machine learning, however, will be needed, because the agent has to have a technique to learn. The next approach to AI is thinking humanly, and this approach is also known as the cognitive modeling approach where we try to model the human brain. Now, for us to say that a program thinks like a human, we need to determine how humans think first. That is, we need to get inside the actual workings of the human mind. So, unless if this is our human brain, and that gives it a place for mind to stand. So in order to say that, say for example, I have an agent. In order for me to say that this agent is thinking like human, first I need to understand how our brain and mind work. And once we understand that, we inject this or we use this to build this agent, and then we can claim that the agent is thinking humanly. So then the first question becomes, how can we understand how we think? How we think. So there are three ways to do that. The first one is through introspection, that is, trying to catch our own thoughts as they go by. So we ourselves think how we think, catch the thoughts that goes through our mind, and then understand how we think. The next is through psychological experiments. That is, one can observe other people, or many people can observe other people or one individual, and devise experiments to see what people do in various circumstances, then come up with a theory about how we think, and then use that as a model to design AI agents. The next is through brain imaging. That is, we put a person's brain through machines like fMRI, and then investigate what's happening inside someone's brain. So once we have a sufficiently precise theory of the mind, then it becomes possible to express the theory as a computer program. Now, this approach of defining AI is more concerned with comparing the trace of its reasoning steps to the traces of humans when solving problems. So the idea is, say for example, in our brain, to solve, let's say, problem X, we do step 1, step 2, step 3, 4. Let's say this is our thinking pattern to solve solution for and this is human brain, human, let's say, mind. Then with this approach of AI, what we want to do is design agents that can solve the same problem X by following same 4 steps, 1, 2, 3, and 4. So the agent is designed such that the reasoning steps that we do as humans is copied or used as a model for the agent as well. And this is, instead of just being able to solve the problems using programs. So if the same agent can solve problem X without doing any of this, but doing some other way, then this will not be thinking humanly. That doesn't become thinking humanly. So the field of cognitive science brings together computer models from AI and experimental techniques from psychology to construct precise and testable theories of the human mind. And thinking humanly is dealt more now under this cognitive science. Can you think of an example where an agent or an entity is acting humanly but not necessarily thinking humanly?